Hey friends, what is up? Thank you so much for stopping by and checking out the channel as always. For those of you who are new here, I'm Daniel from iosoundstudio.com, and in today's video we're going to be talking about perhaps the very most important thing in all of music production and in audio engineering. So, today we're talking about signal flow. What is signal flow, you might ask? Very simply put, an easy way to think of it is that signal flow is really just a sequence of inputs and outputs, or in and outs. You could think of it as electricity flowing down a given path, much in the same way that water flows down a stream and eventually makes its way to the ocean by a series of different bodies of water. Now, this concept honestly can't be overstated. You were going to run into this exact thing in the most basic home studio or the most commercial multi-million-dollar studio with all of the gear in the world. So to kind of make this make sense, we are going to look at a handful of different examples. So say I have a microphone and I want to record a vocal or perhaps an acoustic guitar or some sort of acoustic instrument. Let's talk about how this idea of inputs and outputs translates to an actual recording. The very first thing to note is that your voice or your instrument is the very first step in our signal path. The voice or the instrument is our output. That output is then going into a microphone, aka an input. Once that microphone receives that signal, the next thing that happens is that the signal continues through the microphone, through the electronics in the microphone, and then it goes into a XLR cable. After it goes into an XLR cable, it's going to travel through the length of our XLR cable, or in some cases a 5-pin if you have certain types of microphones. And it's going to come out the other side of that XLR cable, and then it's going to go into an interface. So let's go ahead and plug in our microphone. All right, now that we got our microphone set up with an XLR cable plugged into it and the other end of the XLR cable plugged into our audio interface, let's continue our journey through this signal path. After our audio signal is received by our audio interface, it is then converted from analog to digital, and it's sent from our audio interface through our USB cable as a digital signal and received as an input by our computer. That's what we see show up in our DAW. So after you have your microphone plugged in and you have enabled phantom power, that's the little plus 48 volts sign that's on your audio interface that is needed for some microphones, and you have your gain level appropriately set, you should now see some input signal in your DAW. And if you don't, then you might have the wrong input selected. So go ahead and talk into your microphone and see where that input signal is showing up on which input. Hey check, hey check, hey check. So for me, I'm receiving that input signal on input number 1, which is exactly where I plugged into on my audio interface. Now, I'm noticing that my gain is a little bit low, so I'm gonna go ahead and turn my gain up some more. Let's see. Hey check, hey check. Hey, check. And that is a little bit better. Now, from this point, if I wanted to record a vocal, I very easily could. As long as I have my track record enabled right here. Now I can hit the recording button on the transport control in Ableton, and I would start to record an audio signal in Ableton. All right, very good. Now, if I was recording an actual vocal, I might gain that up just a little bit more so that it's just a little bit stronger. But remember, when we are recording, we don't want to record our tracks too hot. Otherwise, that could lead to many more problems in the mixing phase later on down the line. So really fast, let's go ahead and record a test vocal, and then we're going to look at another example of what signal flow looks like inside of our DAW. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a Warm Audio 47 FET Junior. All right, great. Now that we have our test audio, let's look at an example of another way that you see signal change showing up once you actually have your tracks recorded. Now, this example is actually in plugins. Anytime you use plugins, you are also using inputs and outputs within your DAW to link together different types of signal processing. Now, this kind of thing can be done in the box, meaning in the computer, or it can be accomplished outside of the box in analog hardware. Both are extremely useful and both have their use cases, but if you're starting out, most likely you don't have any investment in any outboard gear just yet, but the concept still applies. So oftentimes, one of the first moves that I make with a vocal is I grab an EQ. So let's just grab an EQ plugin, a stock EQ plugin from Ableton. Now, on this EQ plugin, you can see that there's a signal indicator on both the left side and on the right side. That's indicating the in and the out of that plugin. So when I hit play, hey, mic check 1, 2, 3, both of those show that there is signal passing through this plugin. Now, if I were to increase the output gain of this plugin, you're going to see that the input stays the same, but the output side is much hotter. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Great. Now, what if we wanted to, after affecting this vocal with an EQ, we wanted to put it through a compressor? Let's just do some quick EQ shaping really fast. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm. All right, now that I've done some EQ shaping, let's look at what this would look like going into a compressor next. A compressor has a lot of different features to it. I'll explain all those in another video if you're interested, how to use a compressor. But essentially, there's still an input and there is still an output in a compressor as well, whether that is something like an Ableton stock compressor or like an 1176 style compressor or whatever. When I hit play, on the left side of this compressor, you're going to see an input signal. In the middle, there's a gain reduction threshold that essentially shows how much the volume is being turned down. If that doesn't make sense, don't worry about it. I'll put out another video about compression soon. And then on the right side, there is an output signal. So let's go ahead and hit play so you can see that. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Now, as I bring down this threshold, you're going to see the gain reduction start to increase. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. And so on and so forth. What if I wanted to now add a reverb, for example? The concept is still exactly the same. There is an input into a reverb and an output with the newly affected signal. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Now, one thing that's really cool about a lot of Ableton stock plugins is that there are dry-wet knobs on a lot of the units, meaning you can then blend together the dry, unaffected input signal with the new wet or affected output signal. And that drastically changes how the sound actually is manipulated. For example, if I only want to partially compress the vocal and I want to blend the compressed vocal with the uncompressed vocal, I could dial this dry-wet knob back towards dry a little bit more. Now, if I play this back, what we would be hearing would be the dry vocal with a little bit of the compressed vocal as well. Same thing with this reverb. If I were to hit play and I dialed this knob up, we'd be hearing less of the dry input signal and more of the wet or affected output signal. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Hey, mic check 1, 2, 3, mic check 1, 2, 3, recorded into a warm audio 47 FET Junior. Okay, now let's look at another example of signal flow inside of our DAW. So if in your DAW you have a whole bunch of tracks that you decide to put together in a group, the way that the signal flow would work is now all of those individual signals from all of those individual tracks now go from those tracks to the group that they're in, and then they go from that group to wherever you decide to send them. Typically, by default, they will send to a master bus or a mix bus or a 2 bus. It's a lot of different names for the same thing. So in this song, I have a bunch of different drum tracks. I have timpanis, I have impacts, I have a snare, and they are all grouped together in my drum group. Now, the individual signal of all of these different guys is being sent into my drums track. Then it's being sent from my drums group to my instrumental group, which I have all of the different instruments of the session going into. And then it's going from my instrumental group to my master fader or my mix bus down here. So if I were to solo this kick slash timpani track, this is what the individual track sounds like. Now, of course, there are several other sounds like this one, for example, and this one, and then a snare track. And when they are all played together in the group, the drums group track, this is what that sounds like together. And then when we listen to our instrumental track, this is what those drums sound like in context of the rest of the instrumental. And then from there, in context of everything, this is what it sounds like in the context of the song. And I'm only going to play a very small clip just for context.
I'm content with whatever comes next.
So that's another example of how signal flow works inside of your DAW. But let's look at one final one. What if you want to have a vocal track, but you also want to affect it partially without putting the actual effect directly on your track? Now, this is a very, very common practice in mixing, and it helps us blend together the dry and wet signal, which would be called parallel processing. So one way that we accomplish this is through what's called send and return tracks. In Ableton, the send tracks are these little rectangles here, and you can increase the amount of the signal that you were sending. And then here on the bottom, there are return tracks. In this particular session, I have a reverb for the lead vocal, a reverb for the background vocals, and then I have another return track for a delay. So for simplicity, let's look at the reverb return track. On the reverb return track, I have obviously my reverb, and I have a little bit of processing for that reverb as well. I'm just kind of EQing and shaping what I want that reverb to sound like a little bit. So what I would do is I would then go up to the lead vocal track and I would adjust the amount of signal that is being sent from that track to the return track. And now from that return track, as I change the signal, let's solo that and listen to it really quickly.
I'm content with whatever comes next. I'm content with whatever comes next.
Now, I found for this particular track, since I've already mixed it, I like it to be around -9 dB for this particular part of the song. Now, the majority of the signal at this point of the song is wet. It's the wet processed reverb signal, and a portion of it is the dry signal as well. So that helps us blend them together in a way that's coherent. It still has reverb, but you're not losing the intelligibility of the vocal. Now, the benefit of doing it this way, using sends and returns, is that you can send multiple signals or multiple tracks through that return track, and then have all of that signal then sent to your master bus. This is a really effective way to reduce processing for your computer and to get an overall coherent sound. And you kind of have to be intentional and strategic about how exactly you do this. And the processed signal from those return tracks is then being sent to the master bus as well. And everything from that master bus is then being sent through my interface once again and through the outputs into my speakers and my headphones. All right, friends, so that is a detailed look into the simplest but the most important thing in all of music production and audio engineering: signal flow. I hope that makes sense. If you guys have any questions, feel free to throw them in the comment section below. If you learned anything, feel free to throw that in the comment section below. And if there's anything that I missed and you want to add to it, feel free to throw that in the comment section below. Thank you guys so much for being here, as always, again. And per usual, if you want to support me in this channel more directly, I am not sponsored by anything just yet, but you can check out my Patreon, which is linked below. I post content there that I don't post here, ad-free for only a couple dollars a month, and you get way more insights into production and mixing breakdowns and works in progress for myself and for other artists, with their permission, of course. And you can just learn a lot more and go through the process, the journey with me there. So thank you again, friends, for being here, and I'll see you very soon with another video. Peace out.